Hey guys, so this is going to be a follow-up video to the one I did the other day about my D700. So I was able to replace the fuse and get the D700 to operate. I put it back in my car and it worked fine for the evening. I figured there might be a problem with the cable, but I thought at worst what would happen is if there was a short in the cable, whenever it revealed itself, it would just blow the fuse again because the fuses were identical. Virtually identical. I exchanged a 1.8 amp fuse with a 2 amp fuse. So only 200 milliamps difference there. Shouldn't be a big deal. It's a big deal. So, put the radio in, operated, for an hour on the thing, talked to folks, everything worked great. Got in the car the next morning, loaded up the kids in the back, and radio wouldn't turn on. Okay, I blew the fuse, I'll go figure out what it is. So, brought the, later on that evening after work, brought the car up to the garage here and pulled the cabling out of it and verified. Sure enough, there was a short in the cable. It was not anywhere along the cable. It was in a cable. It was an end that plugged directly into the control head. Now here's the thing about it. I didn't directly measure the resistance. I used my handy dandy cable checker right here. This is part of it. And as it was going through checking the pairs, I could see that there were two pairs that were shorted out. Basically, the lights wouldn't turn on for those pairs as it would go through its little sequence of demonstrating if current could flow through the pairs. And that happened to be the ones the power leads were on, not the data leads. It was the power leads. And started off cutting off one end of the cable, checking it, and it checked out okay. It's like, great. All right, I had a 50-50 chance of getting it right. Cut off the other end of the cable, and it was the end that goes into the control head that had a problem. Did not check that resistance. I suspect that it was just enough resistance to blow the fuse at 1.8 amps, but not at 2 amps. So whenever I pulled the radio back out, put it on the bench, I'm expecting the fuse to be blown. It's not. I'm like, oh crap, something's blown in the radio. And so I started looking at the schematic, and sure enough, this is the voltage regulator schematic here. Put on the screen cap. There you go. So here's our fuse, and that comes along here, and so this is a bypass capacitor they have right here for the voltage regulator. That's a PMP. So let me flip on the power supply here, and I'll show you what we're measuring, what this all looks like, where the problems are. So this right here is our emitter. We got our 13.6 volts running in right there. And this is our collector, 9.4 volts. Now, as you see in the schematic over there, we should be seeing 9.66 volts, but we're seeing 9.4. It's like, all right, that's close enough. Well, put a little bit of current draw on it, such as plugging up the control head. Now plugged in the control head. Check this out. 3.47 volts. That ain't no good. So upon further inspection of that guy, let me show you what we have here. Stuck my nose down there. Oh, that's a smell of magic smoke. And yeah, magic smoke has been let out. Check the thing out, man. You can see the part that's melted there on the right hand side of that transistor. So checked it out. That is an available part, and so I was able to order it through Mouser. Yay, Mouser. These little things cost like 50 cents, so I bought 5 of them. I also bought the transistors that are around it. So if there's an issue after replacing this transistor for a Hail Mary, I can replace these other parts too. So I'm going to give this a go. It's broke, and I guess I can't make it much worse. Knock on wood. I mean, I can absolutely mess up those. I can mess up all of those. Resistors and small transistors and other semiconductors that are right there. You know, like if I put the hot iron, the air iron on it and blow across there and just nuke the whole thing, that's going to be a problem. So I'm a little nervous doing this. I don't know how well this is going to work out, but we'll take a swing at it. I don't do this for a living. This is supposedly fun for me, but having heartburn, man. Yeah, they don't make these radios anymore, and this might go badly. So jump into it, man. See if we can make this go. I don't know how. I don't think we're going to get good camera views here. We're gonna find out though. All right, looks like I can get that in there. Let's see here, and so I can probably get that in there on it. No, man, there's just not much room. I am going to really mess this up. That is going to be so problematic. All right, yeah. Let's give it a go. Let's see what we can do. Ooh, that's nasty. There we go. 436 degrees. I'm going to turn that way down. Definitely don't want to. The first time I tried to do one of these things, surface mount, I had the blower just blowing really fast. Dude, those components didn't stand a chance. smoked it. It's like, all right, I know not to do that now. So, all right, yeah, let's see what we can do here. I really can't even see in there well enough to see if it's melted. That is not good. Okay. Yeah, this is bad. I don't think I can get this thing hot enough. That does not want to come out. Okay. Okay, tell you what, this is what we're going to do. I'm going to pause the video and see if I can come up with a better way of doing this. Because what I'm doing right here is not working. That is super problematic. So, give me a minute. We'll see. Okay, well, looks like we got it out. It looks almost identical. It's the one that I pulled out. I don't think I can get them to focus. But yeah, they look almost identical. You can see that obviously one of them has got a problem there. Man, I really wished I could get this to focus appropriately. But yeah, so it did come out. I'm going to inspect this with my camera phone. see how that went. Super nervous right now, man. I am not well built for this kind of thing. I really hope I didn't pull a trace up over here. It doesn't look like I moved any other components around. Looks like everything's mostly intact. So, yeah. Let's put us a little flux down in there. All right, that cut off, so most likely everything's cool enough in here for me to do this. Oh, that's probably way too much flux. That's what I get for not having good light. So I can do no way. No. There's no way that just fit right on there like that. Well, that's pretty darn close to it. All right. Well, I'm going to continue to hold this light up down in there. I guess we'll turn this back on again. And we'll see if it see if this goes. I'm going to put on my big nerdy glasses so I can see better. There we go. Oh yeah, I can definitely see better with that. So there we go. All right. That's us. We're right on top of it. Everything's looking pretty good from here. So let's give it a go. What I wound up doing was turning the temperature up all the way on this bad boy. Just can't quite get that center one to heat up enough. I'll tell you what. Sit down. Do that. This stuff solidify. Sorry if my camera was blocking the way there. All right. Okay, it seems like it's solid. Let's see what we can do here. Oh boy. Disconnect the control head. Cross my fingers. I do not see smoke. So that is good. All right. Input 13. Output also 13. Gee. That's not good. That's bad. Not what I was expecting at all. I know there's a 7805 in this thing. Well, look at that. It powered up. So I'm going to double check, see what our voltages are. 9.4. Yep, okay. It's because it didn't have a load. Well, that looks good. Holy cow. Yay. Look at that. This stuff would be so much easier if you're doing it to somebody else's radio, man. Good deal. All right, man. Well, I think we're good. We're seeing reasonable voltages in there, and radio turns on. So I'm gonna put it back in the car, and we'll do a complete function checkout. But as of right now, I'm gonna call that guy good. So How awesome is that? Yay for success. Thanks for hanging out with me, and yeah, we're good. We're good to go. So, all right, guys, take care.